In this video, we're going to work on the review for section 6.1 and 6.2. So, question 1 says, for sine, cosine, and tan, identify which ratios are positive and which are negative if the angle is in each of these 4 quadrants. So what you're going to do is get your 4 quadrants, and remember, all students take calculus. Everything's positive here. Sine and cosecant are positive in quadrant 2. Tan and cotan positive in quadrant 3. Cosine and secant positive in quadrant 4. Here are your quadrant numbers. Alright, so if angle T is in quadrant 1, and they want to know about sine, cosine, and tan, you can say all are positive. Positive. That correctly. Okay, in quadrant 2, sine is positive, cosine and tan are negative. In quadrant 3, tan is positive, and sine and cosine are negative. In quadrant 4, cosine is positive, and sine and tan are negative. Okay, and that's all there is to that. Okay, question 2. Let angle T have terminal points x, y on the unit circle in quadrant 1. Okay, so in quadrant 1, express the 6 trig ratios in terms of x and y. Okay, so remember, if the terminal point is xy, then x is always cosine, and y is always sine. Okay, you're in quadrant 1. Quadrant 1, everything is positive. So sine, and I'm on the unit circle, so sine is just y, cosine is x, tan is sine over cosine, cosecant is 1 over sine, cosine is 1, secant is 1 over cosine, and cotan is either 1 over tan, or you can call it cosine over sine. Okay, everything's positive. Okay, next one. Verify that the following points are on the unit circle, and then identify 3 other points also on the unit circle. What you're going to do here is you're going to recognize that they're both positive. If they're both positive, then this must be in quadrant 1. And let's make sure it's on the unit circle by saying x squared plus y squared has to equal 1 squared. So that's 25 over 169, which is 44 over 169. And when you add those together, you're going to see that it equals 1 because 169 over 169 is 1. Okay, so then I think the most I guess creative and safest way to do this, recognizing that they gave me my values that were in quadrant 1, not from quadrant 1. Okay, so the 3 other points that they want are in the second quadrant. Second quadrant, my x is negative, but my y is positive. Third quadrant, both are negative. Fourth quadrant, only the y is positive. Excuse me, only the y is negative. So there are my other values, and then you're done. Okay, those are coordinate pairs, so I probably should have them in parentheses, but you get what I'm doing. Okay, next one, same thing. I'm going to first make sure that it's on the unit circle, and I'm going to do that by taking each of these and squaring them and make sure that they result in a 1. So that's going to be 9/16 plus 7/16. That is going to get me 16 over 16, which is 1, so I verified it. Because the x is negative, that's going to be in quadrant 2, So I need the other quadrants, which is quadrant 1, everything is positive. Quadrant 3, everything is negative. Quadrant 4, just the y is negative. Okay, so then they kind of change it up a little bit. Now they say find all points on the unit circle where x is 1/2. So that means the cosine of the angle in question is 1/2. So that's positive. Cosine is positive in the first quadrant and in the fourth quadrant. Look at unit circle. Cosine is the first value. It's 1/2 at pi over 3. So that's my reference number. That's also one of my answers. And then my other answer is 5 pi over 3. Okay, the next one, they are really saying to you the sine of the angle is negative √2/2. So get your quadrant. Where is sine negative? Sine is negative here and here. And I'm basing this on all students take calculus because sine is positive in the first and second quadrant. So go up to your first quadrant and figure out where your angle, where the sine of your angle is positive √2/2, and that is at pi over 4. So pi over 4 is your t-bar or your reference number. So therefore, find your angles that have the same denominator in the third and fourth quadrant, and they will be 5 pi over 4 and 7 pi over 4. Okay? So then we go back to, here's the terminal point. I know this is cosine and this is sine. Find all 6 trig ratios. Okay, so trig ratios. And since both of these are positive, right, I'm in the quadrant 1. Okay, so trig ratios are sine, cosine, tan. Let's do those first. Sine they gave us is 15/17. Cosine they gave us is 8/17. Tan is sine, which is 15/17, divided by cosine, which is 8/17. Okay, that means that it's 15/17 times 17 over 8, and this math results in tan being, when the 17's cancel, positive 15 over 8. Okay, so now let's do the partners. Sine and cosecant, you want to memorize this, this is from chapter 5, are reciprocals. So therefore, if sine is 15 over 7, cosecant of the angle is 17 over 15. Cosine has a partner, it's a reciprocal partner with secant, and therefore flip that fraction. And likewise, tan has a reciprocal partner with cotan. So flip over the 15/8 and make it 8/15, and you have all 6 trig ratios. Now, we were in quadrant 1 for this, so always make sure that you know what quadrant you're in, because only in quadrant 1 are all 6 positive. Okay, so you may have to, deal with some negativity if you're in a different quadrant. Okay, speaking of different quadrants, now we're going to work on this next little section. This says, identify the quadrant where the unit circle, within the unit circle, where each of these angles lie, and identify their terminal point. So I need 2 things. I need the quadrant and the terminal point. Okay, so I want the coordinate pairs. That's another word for terminal point. So this angle is pi over 3. Pi over 3 is definitely in quadrant 1. And the coordinate pairs of pi over 3, just reading off my unit circle, 1/2 and radical 3 over 2. Okay, 5 pi over 6. It's a little bit less than 1 pi, so that's going to be in quadrant 2. And in quadrant 2, what happens is your x value will be negative. So now go to quadrant 1 and match up the pi over 6 angle, because that's the reference number. So that's this, and then this. Done. Okay, 11 pi over 6, that's a little bit less than 2 pi, so that is in quadrant 3. And in quadrant 3, I know that y is negative, so when I pick out my coordinate pairs, I know that y is negative. Now go up to quadrant 1 and look for the angle pi over 6 and use those coordinate pairs, knowing that you're going to make the y value negative. Okay, that's done. Okay, 7 pi over 4, you're going to be in quadrant 4, so indicate that. This is quadrant 4. And 7 pi over 4 in quadrant 4, what I know is that the, hold on a second, did I mess up over here? Let me just see. 11 pi over 6, yes. 11 pi over 6 is also in quadrant 4. So let me make that little correction. I think I said it, but I wrote down something different. Okay, so these both are in quadrant 4. Therefore, they both have negative y's. Go back up to quadrant 1. The reference number is pi over 4. Grab those coordinate pairs, and we are good. Just going to make sure that my answers match what I have on my own key. And yes, I'm good. Okay, so let's keep going. We're on the next page. And on this next page, we have some more angles. Now, this time, these angles are not on your unit circle. So job 1, get it on your unit circle. The way you do that is you add a full circle. I have to add a full circle, which is 2 pi, but I have to be in thirds. So I'm going to add 6 pi over 3. That reduces to 2 pi, but it allows me to add 6 pi over 3 to negative 4 pi over 3 and get 2 pi over 3. Okay, so what quadrant is that in? The coterminal angle is going to be also in 2 pi over 3. That's quadrant 2. And in quadrant 2, I know my x is negative. See what I'm doing? Then go to quadrant 1 and use the coordinate pairs from pi over 3. And you are good. Okay, so the next one I'm noticing that this is also not in my unit circle. It is too big. So I'm going to subtract away a full circle in 6. So that's 12 pi over 6. That gives me 5 pi over 6. And 5 pi over 6 is in quadrant 2 also. I know in quadrant 2 the x is negative. Now go to quadrant 1 to the pi over 6 angle and grab the coordinate pair from there using the negative that you know you have. Okay, done. Okay, here comes another one. It also is not on the unit circle, so I'm going to add 8 pi over 4, and I'm actually going to do that twice. Remember, each time is a circle, 2 pi. When I do that, that's 16. That's going to be 5 pi over 4, and 5 pi over 4 is in quadrant 3. Okay, in quadrant 3, I know that both coordinates are negative. Now go up to pi over 4, which is the reference number, and pull the coordinate pairs. Because I have my signs already written down, I am good to go. Okay, one more over here. This is also too big, so it's not on my unit circle. So therefore, I'm going to subtract away a circle. That's not quite enough, because that's still too big. Do it a second time. And I get 5 pi over 3. That is in quadrant 4. In quadrant 4, what I notice is that only the y is negative. So go up to quadrant 1 to your reference number, pi over 3, and grab that coordinate pair. And there you go. You have all your answers. Okay, so be careful doing this. Follow my steps. Watch your SIGNs, and you'll be good. Okay, here's another one. The terminal point, xy, below is on the unit circle and is determined by angle t. Find the value of, okay, all 6 trig functions. That means that I want to recognize that this is cosine of the t, and this is sine of the t. And simplify your answers and report them in proper mathematical form. Now, notice what I'm seeing here. If my y is negative and my x is positive, I am in quadrant 2, right? So let me see now. Oh, I'm so sorry. If my y is negative, that makes it quadrant 4. So quadrant 4 it is. In quadrant 4, only cosine is positive. So cosine is positive, and then its partner, secant, is positive. I would know that going into this because that will help you tremendously. Okay, let's set this up. Sine of t is just the second value. Don't forget the plus and minus feature of it. Cosine of t they gave you also. All you're doing is copying it across. Okay, tan of t. Now when we do tan, we know that tan is sine divided by cosine, which is sine times the reciprocal of cosine. Now notice that when that 5's cancel, you still have the -1. Okay, you can't have a radical in the denominator, so you're going to rationalize it. And when we rationalize it, we get -1 root 6 over 12. So this is negative root 6 over 12. Okay, so now let's go and get the partners. The partner with sine is going to be cosecant, and that's also going to be negative. So it's going to be negative, flip it over, 5 over 1. The partner with cosine is secant. So that's going to give us 5 over 2 root 6, but I'm going to have to rationalize that. 5 root 6 over 12, my best answer. And cotan. Now, cotan, what I would recommend that you do is look down here and look at the step before you rationalize, which is right there. Take that value and flip that over. Done. Otherwise, you'd have to re-rationalize, and that is a lot more work. So take the pre-rationalized number and give me the reciprocal of it, including the sine. And then you're good. Okay, so as I said, this angle was in this quadrant, so what I should find is that only cosine and its partner secant are positive, and that's what I found. Everything else I have is negative. If I didn't see that now, I would have caught it, okay? Okay, so then we have these tables. This can be tricky, so let's follow through on this. So first one is easy. Cosine of pi over 4. I'm in the first quadrant. Everything is positive. And cosine and sine both have values of root 2 over 2. Sine of 5 pi over 4. Sine. So let me just do this. This is quadrant 1, quadrant 2, quadrant 3, quadrant 4. All students take calculus. Okay, so 5 pi over 4, where is that? That is in quadrant 3. Okay, in quadrant 3, sine is negative. I'm going to write down a negative right away. Then go to pi over 4 in quadrant 1 and pull off the sine value, which happens to be the same as the cosine value. Okay, tan of 3 pi over 4. 3 pi over 4 is in the second quadrant, and therefore tan is negative. Okay? Tan is sine over cosine, so it's negative root 2 over 2 over root 2 over 2, which makes it negative 1, and that's your best answer. Okay, cosecant of 3 pi over 4. Well, first off, I need to know what quadrant that is in. That is in quadrant 2. Cosecant goes with sine, so it's going to be positive. Okay, now go over to pi over 4 and see what the sine value would be. It would have been root 2 over 2. Flip that over since it's not sine but cosecant, and then you need to rationalize it. Once you rationalize it, you should have 2 root 2 over 2. The 2's can cancel, and that gives you positive root 2. So notice how I'm giving you the sign as well as the value. That is my expectation from you as well. Okay, secant of pi over 4. First off, I'm in the first quadrant. Everything is positive. Secant is the flip of cosine. Cosine of pi over 4 is root 2 over 2. So I need 2 over root 2. It's going to be the exact same answer I just got, but for different reasons. So that's positive 2 root 2 over 2, which ends up being positive root 2, because once again, those 2's will cancel. Okay, cotan of pi over 4. Pi over 4 is in the first quadrant. It is positive. Tan is 1 there. Cotan is also 1. Okay, cosecant of 5 pi over 3. 5 pi over 3 is in quadrant 4. Secant goes with sine. Sine is negative in quadrant 4. Give yourself a negative value. Now, it's the opposite of sine, or the reciprocal of sine. So go to pi over 3 and take your sine value, which is root 3 over 2, and flip it over. Then you're going to rationalize it. Once you rationalize this, you should have this for your final answer. Okay, 7 pi over 6. Look at your unit circle, and I'm seeing 7 pi over 6 is in quadrant 3. Okay, in quadrant 3, everything's positive. Give yourself a positive. Okay, pi over 6 is the reference angle that I want to go with. That I need to have tan, so it's going to be positive 1/2 sine divided by cosine. And that's 1/2 times the reciprocal. That's positive 1 over root 3, and then I'm going to rationalize it. And that's going to give me positive root 3 over 3. Okay, and that's my best answer there. Secant of 11 pi over 6. 11 pi over 6 is in the fourth quadrant, and in the fourth quadrant, cosine, which is the partner function to secant, is negative. So give yourself a negative. Okay, so let me think about this for a second. Off my head. Okay, in the fourth quadrant, cosine is positive, right? Because I have this up here. Yep, it's positive. So I'm going to be a positive value. It's going to go with cosine. Cosine of pi over 6 is root 3 over 2. So I'm going to go with the flip of that, 2 root 3, and then I'm going to rationalize it. And I'm going to get positive 2 root 3 over 3 done. Okay, cosine of 2 pi over 3. Cosine of 2 pi over 3. The angle 2 pi over 3 is in quadrant 2. In that quadrant, cosine is negative. If cosine is negative, I'm going to make sure I write that down, and then look at pi over 3, grab the cosine value, and you're going to get negative 1/2. So I apologize, we had some connectivity issues, but I think we're good. So I think I was on 17 when things dropped off. So I said it was in quadrant 2. It's cosine So I know it's going to be negative because in quadrant 2 only sign is positive. So put down your negative and then go to your unit circle and go to positive pi over 3 and look and grab the cosine value, which is 1/2, and so then you have negative 1/2, and that is your answer. Okay, going on to 18. Cotan of 7 pi over 4. Find the angle. It is in quadrant 4. In quadrant 4, tan and cotan are negative. That's my favorite angle because both the sine and the cosine are the same, so therefore tan and cotan are always 1. So verify that by going to quadrant 1 and go to your reference number, which is pi over 4, and calculate it out. Same over same is going to give you a 1, and therefore it's negative 1 because of the location. Okay, that brings us to 19. 4 pi over 3 is in quadrant 3. In quadrant 3, only tan is positive, therefore this has got to be negative. This is cosecant, which is the flip of sine. So go ahead and find pi over 3 in the first quadrant, get sine, which is radical 3 over 2, and flip it as 2 over radical 3, and then rationalize it. Remember, you already have the negative. Don't lose it. There you go. Okay, so that's your answer there. Okay, we keep going. Cosine of negative pi over 3. Now, you can think about this, or you can just use coterminal angles, whatever you find easier. This is 6 pi over 3. That's going to be 5 pi over 3 is your coterminal angle. So we want the cosine of 5 pi over 3. 5 pi over 3 is in quadrant 4, which is exactly where cosine is positive. So therefore, I know it's going to be positive. Go up to the first quadrant and grab the cosine value off of the reference number, pi over 3. The cosine is first. Therefore, it's going to be positive 1/2. Done. Okay, 21. Cotan. Cotan of 3 pi over 4. 3 pi over 4 is in quadrant 2, and only sine is positive there. Therefore, cotan is going to be negative. If cotan is negative, then tan is negative. By the way, your reference angle is pi over 4. This is my favorite angle. So negative pi over 2 divided by pi over 2 is going to give me negative 1. And we are done. Okay, sine of negative 2 pi over 3. Again, you can even kind of think about this or just add 6 pi over 3 to get the coterminal angle, which is 4 pi over 3. Okay, 4 pi over 3 is in quadrant 3. That's going to be a negative value for sine. Go up and look at pi over 3, which is the reference number. Grab the sine, which is root 3 over 2, and you are done. Okay, tan of 14 pi over 3. That's too big a number, so 14 pi over 3 minus 6 pi over 3, that gives me 8. I'm going to do it again, minus 6 pi over 3, which gives me 2 pi over 3. That puts that value in quadrant 2. Tan is negative there. Now go up to your reference number, which is pi over 3, and I want negative root 3 over 2 divided by 1/2, which is negative root 3 over 2 times 2 over 1, which ends up being negative root 3, and we are good. Okay, continuing. Secant goes with cosine. 11 pi over 4 is too big, so take 11 pi over 4 and subtract away 8 pi over 4, which is a full circle. That gives me 3 pi over 4, which is a quadrant 2 angle. Quadrant 2 is where sine is positive, so therefore cosine is negative. So now I'm going to go back up to pi over 4 as my reference number, and secant is the flip of cosine, So that makes it 2 over root 2, which needs to be rationalized. So that's going to be radical 2 root 2 over 2, which equals negative radical 2. Done. Next one, cosine of negative 5 pi over 4. Okay, that angle's too small, so negative pi over 4 plus a positive 8 pi over 4 gives me 3 pi over 4. Okay, 3 pi over 4, what quadrant is that going to be in? That looks like quadrant 2, and in quadrant 2, cosine is negative, and my favorite angle is the terminal angle, is the reference number, pi over 4, and I get root 2 over 2, and it's negative. Okay, just a couple more of these. I know these seem tedious, but you can get it. Okay, 8 pi is too big. Subtract 2 pi, that gives me 6 pi, 2 pi, and then I keep going, because it has to be less than 2 pi. So look, I took 8 pi away. That's going to be 0 pi or just 0. So I want to know where that is, and that is a quadrantal angle. So I really just want the sine of 0, and I read it directly off of the quadrantal angle, and that is going to be 0. Okay, cosine negative 2 pi. So negative 2 pi is too small. Add 2 pi, you get a 0. So I want the cosine of 0, quadrantal angle again, and that's going to be 1. Tan of 7 pi is too big. Subtract 2 pi. Subtract 2 pi, that's 4. That's still too big. Subtract 2 pi again, and I get pi. So now I want the tan of pi. That's quadrantal. Just look at your unit circle. Since tan is sine over cosine, that's going to be 0 over negative 1. Well, 0 over negative 1 is still 0, so 0 is my answer. Okay, cotan of 5 pi is too big. Let's subtract 2 pi, still too big. Subtract 2 pi again, still too big. Subtract 2 pi, 2, 4. No, I think I want to stop there, so sorry, don't go there. Okay, minus 4 pi gives me pi, so I really want the cotan of pi. So remember, cotan of pi is a quadrantal angle, and cotan is cosine, which is 0, which is negative 1, over sine. Negative 1 over 0 is undefined. Okay, 2 more left. Secant of 5 pi over 2. 5 pi over 2 is too big, so subtract away 4 pi over 2, and that gives you pi over 2. So I want the secant of pi over 2. So I go to my unit circle, I see I have a cosine value, of 0. Therefore, what do I do? So let's see. So I would say it's 1 over the cosine, right? But if cosine was 0, I'm dividing by 0, and therefore that is going to be undefined, because you can't divide by 0. Last one, we made it. Okay, this one's too small. Once you add a 4 pi over 2, and that gives you a pi over 2. So I want the cosecant of pi over 2. Find pi over 2. And remember that cosecant is 1 over sine. Since sine was 1, 1 over 1 is still 1, and we are done. Okay, so this is a really critically important table. Make sure you understand it. Okay, now we have the following. This says for each of the following, find all the angles. So now you're looking for angles. Okay, that's different than what we were doing before, for which the equation holds. Okay, so let's see. Sine of some angle is negative. So all students take calculus is going to be key. The angles have to be here and here. Go up to your reference number and look for √3/2 as a sine value. That means that your reference number is pi/3. Find the denominators that match in the third and fourth quadrant, and that would be 4pi/3 and 5pi/3. Those are your answers. Okay, 33. Cosine is positive. Okay, so all students take calculus. The fact that cosine is positive puts it here and here. Now look at the actual value, 1/2. Find the reference number. It is pi/3. Pi/3 is one of my answers. And then find the angle in the fourth quadrant with that denominator of 3, and that is 5pi/3. Okay, next one, you still are going to need, all students take calculus. Tan is negative. Where does that happen? Tan is negative here and here. Now, if tan is negative √3, the values must have been √3/2 divided by 1/2. So where does that happen? That happens knowing that tan is sine over cosine at pi/3. So pi/3 in the second quadrant is 2pi/3. And in the fourth quadrant, it is going to be 5pi/3. Okay, 35, cotan is 1. That also means tan is 1. Where is tan? +1 here and here. My favorite angle, pi/4. And find the denominator of 4 over here. Okay, coming around to the finish here. Okay, if cosecant of tan equals -2, right, then, let me not write that again. So then that means that sine of tan equals -1/2. So where is sine negative? Sine is negative in the third and fourth quadrant. Look up, see where sine, what angle has a sine of 1/2. Looking for a reference angle or reference number, that's pi/6. So go in the third quadrant, look for your angle with 6 in the denominator. Go in the fourth quadrant and do the same. Okay, last one. Okay, it's going to be a little tricky, but not bad. Okay, if secant is this, and it's positive, then cosine must be this, and needs to be rationalized. 3√3/2 times 3. So cosine of t is going to be √3/2. Notice it's positive. That's the most important thing first. Okay, so if it's positive, that means that I'm going to have it located either here or here, and figure out what angle has a cosine of √3/2, and that is going to be pi/6. Pi/6 is one of my answers, and so is 11 pi/6. Okay, that's it. If you can do this, you can do well on the quiz. So go through all of this material, and please make sure it makes sense to you, or come and see me.